Hey guys, welcome back. I can't believe it's already week 5 of summer. Like it's almost halfway over, and that's really sad. But what's not sad is that with this math, today we start the real to do algebra. Like we are going to talk about sort of what algebra is in a nutshell, and then start practicing it, start learning how to use it. And algebra, um, basically by nature is just trying to figure out an unknown variable. So pretty much this is the part of your life, if you haven't already seen a little bit of it last year, it's when we no longer just use numbers. So we no longer study known quantities or numbers. My handwriting is just terrible. There we go. Instead, we start to study unknown amounts. So I'm going to write there are unknowns in our math that we represent with variables. Now, a variable, if you don't know what that is, a variable in math is it's a letter. It's an unknown letter. It might be X, it might be N, it might be R. It's whatever letter you want to use. X is a really popular one. You know, if you have people talking about algebra with X and Y, that's why. It's because X is just super popular. And remember, a variable in science or just in real life, a variable is something that is not controlled. Maybe it changes. And the reason that we call these unknown amounts in math variables is because it's some number that maybe we haven't figured out yet, and in some cases the amount of that number can change. So luckily though, in Algebra 1, for the most part, most of you will get an actual answer, and we will be trying to figure out what that missing letter is. So one example of how, I know you've seen this before, and this is really making algebra a little bit too simple, but if I said something like some number, and I'll call that number n, so that's the variable, n plus 2 equals 5. Well, you can do this. I mean, honestly, an elementary student can do this because you're just thinking about it. What number plus 2 equals 5? And the answer, of course, would be 3. So this is taking algebra and making it, this is the basics. This is making it kind of easy. But in this case, n is the variable, and it's the number that you're trying to figure out. So I'll put variable / unknown. And we're going to go through today some of the ways that we could solve for that number, just in case it's not something you can do in your head. All right, so first we've got to relate it back to what we just did, just so you see that you've kind of been doing this all along. If somebody asks you to evaluate x, y minus z, there are no numbers here, and that freaks some people out. They're like, whoa, wait a minute, where'd all these letters come from? Well, that's algebra. Now you've got variables instead of numbers. And keep in mind, when you see this, when an x and a y are stuck together like that, and you're like, well, wait, what's happening? Is it add, subtract, multiply, or divide? If nothing's there and they're stuck together, it's an automatic multiply. So feel free to put that little dot in between them so that you remember that. But anytime they're just stuck together, it does mean multiplication. So basically, this is not too terrible because over here to the side, these are your clues. These are your notes for what x is, y is, and z is. So all you have to do is take the number value and plug it in place of the letter. So if x is 2, then right underneath x, I'm going to write a 2. I'm going to recopy my little times dot because I really like to see those. Y is 1, so I'm going to write that right here. And then I'll recopy the minus sign. And then z is 5. So now this looks just like what you did before because it becomes a lesson in PEMDAS. Okay, so what do we do first, the multiply or the subtract? Well, we do the multiply first. So 2 times 1 is 2. We recopy the minus 5, and now we do 2 minus 5. So 2 minus 5, you can think of that as plus and negative. The signs are different, so you take their difference, and then you keep the sign of the bigger number. So that's kind of how that'll work. So let's do another one for practice. Oops, I'm drawing all over the place here. There we go. Okay, so here's another one, and if you want, hit pause and try this one on your own before you watch me do it, because it's very similar to the one above, so feel free to hit pause. Otherwise, I'm just going to go ahead and start. I always like to recopy what this tells me to do. X minus y plus z. Then I'm going to start plugging in all these numbers, okay? So x is 3. I'll recopy the minus. Y is 1. I'll recopy the parenthesis, recopy the addition sign, and then z is negative 10. So here we have PEMDAS again, and we need to do parentheses first. So 3 minus 1 is 2, and then plus a negative 10. So this is just like the one above almost. If their signs differ, you take the difference, which is 8, and then you keep the sign of the bigger number. So negative 8 should be our answer. Okay, so now let's step it up a notch. So what if it's not just a bunch of variables and you're being asked to plug numbers in? What if it looks like this? Before we start solving, we really need to practice the idea of like terms, okay? Your teacher oftentimes is going to say combine like terms. You're going to hear that phrase more than you want to over the next few years. Combine like terms. Well, what is a like term? A like term just means do they look kind of the same? Like, for instance, are they both numbers? Are they only numbers? Or do they have a variable stuck to them? So for instance, I'm going to show you in this one, 3 is just a normal number. So I'm actually going to circle this just to kind of make a point. Okay, 3's a normal number, but I'm not going to circle P because it is a letter. And then 7P is also, it's got a letter on it, so I'm not going to circle it. But this minus 2, well, that's just a normal number, so I'm going to circle minus 2. So these two are considered like terms because they are both just numbers. Now, what about that P stuff? Well, anytime there's a number and a letter together, if they are the same letter or the same variable is what it's called, those would be considered like terms. So I'm going to put those in a box. So here I have the blue, I have boxed the like terms that have a variable, and I've circled the like terms that are just normal numbers, and you put those together. It's almost like you group them together, and it might be helpful for some of you to rewrite the problem once you identify what's what and put people together. So maybe we want to put the circles together, so let's just recopy them in that order. So we've got 3 minus 2, and then that we'll keep the blues together, so minus P plus 7P. So I've just recopied it and rearranged it to put everybody next to who they go with. And now I can do the math. So 3 minus 2, you have to do those together because they're like terms. That would be a 1. And then these two you do together because they were like terms. So a minus P and a 7P. So if that throws you and you're like, but there's no number in front of the P. Well, if there's no number, it's an invisible 1. Okay? So I've got a minus 1P plus a 7P. So you pretty much just do the numbers and then stick a P on it. So if I have a negative P and a positive 7P, then that's going to leave me with a positive 6P. Because remember, the signs are different. You take their difference, and then you keep the sign of the bigger number. So it's going to be positive. And I just put that P on there. So think of it as like I have 7 apples, and I'm taking away 1 apple. I have 6 apples left. So that's kind of what's happening right there. And then this would be your final answer, everybody. You cannot call that a 7. You can't put them together because they are not like terms. Like they have to match for you to get to math them together. So let's come over here and try this one, okay? So you may recognize when there's a number on the outside and then there's parentheses, you may remember that we are going to need to distribute, okay? This just means distribute. The number that's in front gets multiplied times both the things that are behind it. So we kind of did that a little bit with PEMDAS, right? So what we're going to have to do is take that -2 and multiply it by the first thing. So I'm just recopying -2 times the first thing plus, because there's a plus sign here, -2 times the second thing, okay? And now you just multiply each term. So how do you multiply a number with a variable? Well, you just multiply the numbers that are in the front. So what is -2 times 5? Well, 2 times 5 is 10, and since one of them's a negative, the answer's a negative, and then I just recopy my r. So that's how you multiply numbers with variables, okay? Plus, back here, a -2 times 9, well, 2 times 9 is 18, but one of them's a negative, so the answer is a negative. Now, can I put these two together? Can I go a step further and do the -10 with the -18? No, I cannot. Why not? They are not like terms. One of them has a variable, one of them does not. All right, so now we step it up a notch. So this is the section where now that we've talked about how to multiply things or how to group things and put them together, now we're going to start trying to solve, okay? So we're going to do this two ways. Each problem we're just going to think about in our head, but then we're also going to show the algebra way that you're supposed to do it, okay? So like for this one, when you see this, you really can read, okay, I'm supposed to find, just so you know, when it says step it up a notch, we're supposed to find what the unknown quantity is supposed to be. So we're supposed to find what the variable is. Find the unknown variable, okay? I guess I need the word what? Find what? Sorry, find what the unknown variable is. Okay, that's a little bit better English. Whew, all right. So when you read this problem, P is what we're supposed to find. And P just means it's some number that we don't know. So some number we don't know minus 11 is equal to 30. Well, if you kind of think about this, you have to do backwards math. Like you have to think, okay, well, there's some number that's got to be bigger than 11, and then when I subtract it, it turns into a 30. And some of you might already know, oh, well, that's just going to be like 41. Maybe you figured that out. Now, how did you figure that out? Well, you probably just added this number to 30 in your head and worked backwards from what you saw. And that's exactly the algebra rule for something like this. What we're going to start teaching you guys how to do is to get the letter by itself, you want to get rid of any number that's next to it. And the way that you get a number and you get rid of it is you do the opposite of what you see. So in other words, if I see a minus 11 and I know I don't like that number, I need to do plus 11. So that I can get rid of it on this side of the equation. But if I do a plus 11 on this side of the equation, I have to do a plus 11 on this side of the equation. Now, why is that, okay? Well, when you have an equation, guys, which is basically anything that has an equal sign, you have to be fair to both sides of the equal. In fact, I used to have my students draw a line down the middle of their equals, just to keep in mind that whatever I'm doing on the left side of the red line, I better be doing the same thing on the right side of the red line so that I'm being fair. This is all about being fair to your equation, okay? So notice what happens over here on the left. If I look at this, I've got a negative 11 and a positive 11. Well, what happens when you put those two numbers together? Well, it equals a 0, and that's the whole goal. That's why you do this. If that zeroes out, then the only thing left on the left side of the problem is this P. So I can bring down the P, and this is a 0. If you want to put plus 0, you can, but remember 0 doesn't really do much, so you can just leave it as a 0. And then on this side, you actually add the numbers. 30 plus 11 is 41. So here we have the p by itself, which is going to be the goal, and it equals 41. And so if you couldn't do that problem in your head earlier when you saw it, now maybe this little rule is going to help you, okay? So let's make a little note because of what we said here, okay? Our goal in this section is going to be to isolate the variable or the letter. And isolate just means, what does that mean, guys? It just means get it by itself. And the way that you can make that happen, if you want to use the same method that I'm doing, is draw a line through the equals. And be fair to both sides of the equation. Okay? Now, how did I know to do a plus 11 right here? Well, if you want to move a number across the line, or if you want to cancel out a number, you are doing the opposite math of what you see. Opposite math to get rid of numbers. All right, these are 3 very critical rules, but if you know them, then you'll be able to get yourself out of any problem that you see. So we're going to do 2 more. All 3 of these are a little bit different from each other, okay? And you're going to have a few of these on the homework, and they're going to be tough for some of you. They really are, especially if this is the first time you're ever seeing this, but you're going to do the best you can. And I'll go slow on the solution video so you can get a little bit more clarification, okay? All right, now let's look at this one. So it's a little bit different because it's not add or subtract like this one was, it's multiply. So negative 4 times some number is equal to 16. Well, some of you can think about it, okay, 4 times what is 16? Well, 4 times 4 is 16. But here's the deal, this is a negative 4 times something, and we have to end up with a positive answer. So how do we do that? You have to do a negative times a negative in order to get a positive. So I know the answer is going to be negative 4 if I just think about it. Now, how do we use this same process that we did here on this problem? Well, let's follow our rules, okay? We're going to try to isolate the variable or get it by itself. And the way that we do that is we draw a line through the equals, and we're going to be fair to both sides of the equation. So whatever I do here, I need to do here. And the way that we get rid of extra numbers is to do the opposite math of what we see. So what do you see right here? You see negative 4 times n. Well, what is the opposite of multiplying? Because these are being multiplied. So what's the opposite of multiplying? It is dividing. So if you want to get rid of that negative 4, the way that you could do that is you could divide by negative 4. And if I divide this side by negative 4, I'm going to divide this side by negative 4. Now, how does doing opposite math help you on this problem? I'm going to draw my line and think about it. Well, guys, what is negative 4 divided by negative 4? That is taking a number and dividing it by itself. And anytime you do that, you may remember that you get the answer 1. A number divided by itself is 1. So what you've just done is turn the number part into a 1, and then when you recopy the letter n, you did just get the n by itself, because we are trying to make this a 1n, just like this is really a 1p over here. So this was good. We want the numbers to go away and make a 1, and on this side, 16 divided by negative 4 is negative 4. And that is the same kind of thing that we were doing in our head, okay? Now, if you don't want to write the 1 in front of the n, you don't have to. In fact, most people in the math world don't. They just erase it and say, oh, okay, a 1 in front of the letter is just the letter. So this would be how you could write your final answer, okay? Now, one more over here. This one is kind of interesting. This is what I teach all my students to do whenever they see a fraction, because fractions kind of freak people out. The first thing that I would do if there's a fraction stuck to your letter is I would think of that as 2/3 with the letter behind it equals 5. This is, I promise, the same thing as this. You're just taking the letter out of the numerator and putting it in the back. This is always legal. If the letter had been in the denominator, this would not work, but you won't see that for a while. So if it's in the numerator, then just shoot it to the back. And now the goal is to undo what we see. So here's the deal. Just like this one over here, we could draw the line down the middle. And we could say, okay, I've got 2/3 times a p. So how do I get rid of the 2/3? Like, what's the opposite of that? Well, instead of doing 2/3 times p, I could divide by 2/3. So if I divide off that fraction, then on this side, I have to divide off that fraction and then figure out my answer, okay? So what happens when you have 2/3 divided by 2/3? Well, a number divided by itself is 1. So this is 1p. We're going to recopy that p. And then on this side, this is where it's tricky for people. I really have to figure out, how do I do 5 divided by 2/3? So I'm actually going to come down here and work on that, okay, and then we'll put our answer back up here. So we're trying to do 5 divided by 2/3. Well, you probably remember from last year, anytime you're dividing with a fraction behind it, you have to flip that number and do the reciprocal. So I'm going to write 5 as 5 over 1, because that's how you can turn a whole number into a fraction. I'm going to change this to multiply, and then I'm going to flip this number behind. The little riddle my 8th grade teacher always taught us was, when dividing fractions, don't ask why, flip the second and multiply. And I know that's lame and cheesy, but it has stuck with me for however many years it's been, 20-something years, okay? So dividing fractions, don't ask why, flip the second and multiply. And that's exactly what I did. I flipped the second fraction and I changed the divide to a multiply. And now you can just do top times top and bottom times bottom. So my answer is 15 over 2. So these are your 3 different types that you're going to see. Do the best you can. Try to follow my notes here of doing, this is the key, opposite math to move something to the other side, okay? And so good luck, guys. We'll see you later.